So the first thing to know is what really is a complex number. So a complex number is a number that can be written in the form z is equal to a plus bi. At times we can write it as ib, doesn't matter. So a number in this form is called a complex number. Now this a is the real root or the real part, and then this whole part we can see here is the imaginary part. Now here the a we can see and the b we can see here, these are real numbers. So the I is the imaginary root. So such is a complex number. Okay, so how did the knowledge of complex numbers develop? There are some quadratic equations. Imagine you are solving a quadratic equation, x squared minus 4 is equal to 0. When you are solving such a quadratic equation, you are going to take 4 the other side, and then you have to square root. So that will give you x being equal to positive 2 or x is equal to negative 2. Now what of an equation where we've got x squared plus 4 is equal to 0? We want to solve it. So this is going to give you x squared. To take the 4 the other side becomes negative 4. And then you have to square root both sides. And that will give you x is equal to square root of negative 4. Now I want someone to tell me what two numbers can you multiply by themselves to give you negative 4? Does anyone know? Any two numbers that you know that you can multiply by themselves to give you negative 4? Okay, so there are no two numbers that you can multiply to give you negative 4. So from here we are going to go up with it, and we'll say we did sad, so we can write negative 4 as 4 times negative 1. And from the surds we did, we saw that we can split this into 4 times root of negative 1, and we know the square root of 4 is positive or negative 2. The square root of negative 1 gives us what we call I. So this is where the complex numbers come from. So that's why we say it's imaginary, because if you punch on your calculator you will not get 2i. It will not show you that. Okay, so from here we need to get into the understanding. You can represent complex numbers on what we call an Argand diagram, just like we can represent real numbers on a Cartesian plane. So an Argand diagram has got the x-axis representing real numbers or the real part of the complex number, and then you've got the y-axis representing the imaginary part or the imaginary root of a complex number. So if you have got a complex number z which is equal to a plus bi, you can write this as a coordinate. As a coordinate, this is going to be a comma b. This is representing the real number, and then the b is representing the imaginary part. Well, why haven't I put the I inside there? The I is just representing that that number belongs to the imaginary part. So putting that on a Cartesian plane, maybe a is going to be here and b is going to be here. So the point is going to be here. This is where the coordinate z is going to be that complex number. So for the fact that b is on this axis, the imaginary axis, it means when you are writing it as a complex number, it's going to have an I for the fact that it is on this axis. Alright, now from here we need to know some operations when you are dealing with complex numbers. But before we do that, I want to show you something, because at times they're going to give you very big numbers. They ask you to simplify. So we have said, the first thing we have said, that the square root of negative 1 is equal to I. This is the very basic. So if I square this, I'm going to get this side I square, and also the I square it. So what will be the square root of negative 1 squared? Can someone tell us, please? What's the square root of negative 1 squared? Okay, that's negative 1. So we have got I squared, that is going to give us just I squared, and then square root of negative 1 squared, that is going to give us negative 1. So what we are going to be doing is we're going to be multiplying by an I, or continue multiplying by an I like that. So if I multiply I squared by an I, we are going to get I to the power 3. And this is going to be equal to, if I multiply negative 1 by an I, we are going to get negative I. If I multiply I to the power 3 by I, we are going to get I to the power 4. If I multiply negative I times I, we are going to get negative I squared. But remember, I squared means negative 1. So this will just be negative 1. That is going to give us a 1. I'm going to multiply I to the power 4 by another I, that will give us I to the power 5. And then I'll multiply 1 by I, that is going to give us I. I'll multiply I to the power 5 by I, that will give us I power 6. I'll multiply I by I, that will give us I squared. And remember, I squared is negative 1. I'll multiply I by I power 6, that will give us our I power 7. Negative 1 times I, that is going to be negative I. I'll multiply I power 7 by I, that will give us I power 8. And I power, okay, we've got negative I here times I, that will give us negative I squared. Remember, I squared is negative 1, so that will be negative 1 times negative 1, which is just a 1. I'll multiply again I to the power 8 by I, that will give us I power 9. And then 1 times I, that is going to be I. Okay, hope we have gotten how it has moved. Now we want to derive a general expression. So we can see this is negative 1. I'm going to look at those which have given us negative 1. So we have got I to the power 2. We have got I to the power 6. Now what do you think? What is happening here? So we had I to the power 2. And what happened for us to get I to the power 6? What do you think? What did we do? We had I to the power 2. What happened for us to reach to I to the power 6? Any response? So you people can see the trend. Like, this is power 2. If we add 4, what happens? We come to the power 6. So I can write a general expression as 2n plus 2. This is always going to give you negative 1. What are we saying? 2n plus 2, what does that mean? So even the n here might be able to confuse someone. Okay, let me get it like this. Let me just add 2 more. We reach to the power 10. I power 9 times I, that will give us I power 10. And that is going to be equal to I multiplied by I, that is going to be I squared. And what is I squared? I squared is equal to negative 1. So let's look at those which are giving us negative 1. We have got I squared. We have got I power 6. And then we have got I to the power 10. Now look at the difference that is passing there. So we have got power 2, power 6, power 10. So it is always 4 more. If we are at 2, 2 plus 4, that will give us 6. 6 plus 4, that is going to give us 10. So this is the trend that we are able to see. So to make now a general expression for that, so when we have got I to the power 2, and then we add, what are we adding? We are adding 4. Okay, this is going to always give us negative 1. Now this is not just 4, it can be, we can say 4n. And what do we mean by 4n? The n here is just representing the number of times. For example, If n is 0, then we are going to add I to the power 2, and we know that I to the power 2 is negative 1, which works. Well, let's say n is a 1. So this is going to be 2 plus 4, which is power 6. And we know I power 6 is a negative 1. Let's say n is what? Let's say n is 2. This will be 4 times 2, which is 8, plus 2, which is 10. And that will give us I to the power 10 being equal to negative 1. So this is the general expression. As long as we have got I to the power 2 plus 4n, it will always give us negative 1. Okay, let's go to those which have got uh, negative I. We have got this one, negative I. We also have this one. So we are saying that when you've got I to the power 3, what is happening? We are moving from power 3 to power 7. How many are we adding? How many numbers? We're adding 4 numbers. So we're going to solve plus 4n. This will always give us negative I. If n is 0, it will just be I to the power 3. That is equal to negative I. If n is 1, and then that is going to give us 4 plus 3, which is 7. And you know that I to the power 7 is a negative 1 also. Let's go to those which give us a positive 1. A positive 1, which one can we find? We have got power 4 and power 8. So we are saying that for a positive 1, I to the power 4 plus 4n. This will always give us a positive 1. Let's go to those which give us a positive I. We have got I power 5 as the smallest. And then we have got I to the power 9. So we are saying we can write this as I to the power 5 plus 4n. This will always give us an I. So we need to know this. If you can't master these, at least know how I have gotten them or how we've derived that. So for example now, let's see if we are able to apply this. If someone said simplify I to the power 200, how would we give the answer? We want to give it if it will be I or negative I, 1 or negative 1. What will be it? I to the power 200. So it's not a guesswork. So to be able to answer it, make sure that you express this power in any of these forms that you are able to see here. In other words, you need to find the value of n, and it should give you a whole number. Now just to look at 200. 200 is an even number. So I'll go to these two which are even numbers. So I can either say let 200 be equal to 2 plus 4n. I'm going to take the 2 the other side. So that is going to give us 200 minus 2, that will be 198. And that is going to be equal to 4n. And then divide both sides by a 4. 4 into 19, we know 4 can go into 16, 4 can go into 25 times, so that means 4 can go into 19, that is 4 times, and remainder 3. 4 cannot go into 38, 4 can go into 30. Okay, let's see if it can go there. So we know that 4 can go into 24, can go into 28, it can go into 32. 32 plus 4, that is going to give us 36. So 4 can't go into 38. It will give us a remainder. So whenever it gives you a remainder, don't count it in. This n should be a whole number. So that means this condition, using this one, it has failed. So that means I to the power 200 cannot be equal to negative 1. Okay, since that one hasn't worked out, let's try the other one. Remember, we're talking about I to the power 200. Let's try to equate it to I to the power 4 plus 4n. And you know that 4 plus 4n is a 1. Now, we have not said this is the answer. We want to confirm. So we're going to equate the powers. So 200 is going to be equal to 4 plus 4n. If we find a whole number for n, then it is true. I to the power 200 is the same as 1. So take 4 the other side. 200 minus 4, that will be 196. And that is going to be equal to 4n. Divide both sides by 4. So n is going to be equal to 4 can go into 19. 4 can go, of course, into 16. That is 4 times. So into 19, there will be a remainder of 3. 4 into 36. How many times can it go there? 9 times. So we see this is the whole number. N is equal to 49. N is the whole number. That means I to the power 200 is the same as 1 in simplest form. So you can go on and try out I to the power 202, I to the power 409, I to the power 500. You see, write this in simplest form. So that is it. We also need to know how to add and also how to subtract complex numbers. Okay, addition and subtraction of complex numbers. When you are adding and subtracting complex numbers, please, just like we did on sides, you add like terms. So the imaginary part add to the other imaginary part, the real part add to the other real part. Imagine we've got a complex number z1 which is equal to 4 plus 2i, and then you have got another complex number z2 which is equal to, let's say, 3 minus, let's say, 7i. And then you want to perform the following. You want to say find z1 plus z2. That's the first one. And then the next one, let's say we want to find z1 minus 3 z2. Okay, let's work these two out. So for the first one, we're going to get z1 plus z2. We'll just add the like terms. So for z1, let me write that 4 plus 2i, and then we're adding to z2 which is 3 minus 7i. Add like terms together, the 4 plus 3 are going to be added, and then we're going to have the 2i minus 7i also added. So this is going to give us 2i minus 7i, that would be negative 5i. So this is z1 plus z2. And then for the second one, b, we're talking about z1 minus 3z2. So I'm going to write z1. z1 is 4 plus 2i minus 3 times z2. What is z2? That is 3 minus 7i. So this is going to give us 4 plus 2i. Negative 3 times 3, that will give us a negative 9. Negative 3 times negative 7i, positive 21i. Add like terms, 4 minus 9, negative 5. 2i plus 21i, 23i. So this is z1 minus 3z2. Anyone left behind? See, it's the question. You went out, you want to understand. Is there another question? Do we have questions? So when you are adding complex numbers, just make sure the like terms are added together. This is z1. This is z2. This 3 is not a miracle. It's coming from the question there. So you distribute this 3 with everything there, and then the answer that you get now, you start adding to the others. Okay, now how do you multiply complex numbers? So the multiplication of complex numbers is just the same way as we know how we multiply always when you're talking about algebra. So when you've got, let's say, z1 is 4 minus 2i, and then you've got z2 which is, let's say, 3i. Let me not use this one. Let's say 1 plus 3i, and you want to perform z1 multiplied by z2. That is the first one. Okay, and then let's say we want also to perform, okay, I'll not put another one, the other one we're going to look at it. So z1 times z2. So z1 and times z2, we are going to get z1, which is 4 minus 2i, and then z2, which is 1 plus 3i. So continue multiplying. 4 multiply with the 1 there, that is going to give us a 4. 4 multiply with the 3i, that is going to give us a 12i. Negative 2i will multiply with the 1 to be negative 2i. Negative 2 I will multiply with the 3i. It is going to be negative 6i squared. And we know the meaning of I squared. I squared is a negative 1. So this is going to be 4. So negative 1 times negative 6, that is going to give us positive 6. That will come here. And then we've got positive 12i minus 2i. 4 plus 6, that is a 10. 12i minus 2i, that is 10i. So this is the complex number z1, z2. As simple as that, that's how we get to multiply complex numbers. Just like when you're talking about you've got a coordinate, you can find the length of a straight line. You can also find the absolute value of the length of a complex number. So that is also called modulus. Modulus of a complex number. Okay, so imagine you've got a complex number z1 which is equal to 4 minus 3i. You want to find its modulus. So the modulus of a complex number, we're going to get z1, we're going to put it in these bars. Modulus or absolute value or length, it's all the same thing. So the absolute value or the modulus of a complex number, you get the x coordinate, that is 4, you square it. You get the y coordinate, negative 3, you square it. Don't get the I, just get the number in front, and then what you get, you square root. It's more like x1 squared plus y1 squared and then square root. So 4 squared, we know that's 16. 9 squared, that's a 9 square root, and that is going to give us square root 25, and that is going to be a 5. So this is the modulus of a complex number. Apart from modulus of a complex number, we also need to understand what is called the conjugate of a complex number. So they are going to ask us at times to conjugate. Okay. The conjugate of a complex number is more like when what we are talking about rationalizing on SADs. So when you've got a complex number z, which is equal to 4 plus 2i, its conjugate, written as z1 with a bar on top, is going to be given by 4. You are going to change the sign of the imaginary part. Please, the sign of the imaginary part becomes negative 2i. Now, you need to realize that when you multiply a complex number by its conjugate, you are going to get a real number. So let's multiply these two. We find z1 multiplied by z1 bar. Okay, so z1 here is 4 plus 2i, and then z1 bar or z1 conjugate is 4 minus 2i. So multiply 4 by 4 there, that is going to give us 16, and then 4 times the negative 2 there, that is going to give us negative 8i, and then 2i times the 4, that will give us positive 8i, and then 2i times negative 2i, that will be negative 4i squared. So this is going to give us 16. This and this will cancel out, and negative 4 times I squared we know is negative 1, so negative 1 times negative 4, that will be positive 4, and this is going to give us a 20. So generally, when you are talking about multiplying a complex number by its conjugate, when you've got a complex number z1, you multiply by its conjugate. All you do is you are going to get a, you square it, and then plus b, you square it. Just that. Remember, a complex number is in the form a plus bi. When we are talking about surds, we said when you multiply a surd by its conjugate, you are going to say the first one squared minus the second one squared. For surds, you put a negative here. But for complex numbers, you always put a positive. Why? Because you have got the I. The I, whenever the I multiplies the negative always change into a positive. So I could have just said 4 squared, that is a 16, plus 2 squared, that is a 4. And that would have given us 20 direct. So these are some skills we should be able to develop, because in the exam we don't have the whole year. So you need to be quick. The questions are a lot and a lot of people complain about time. Now the nice part, just like on sides, comes to division of complex numbers. When you are dividing complex numbers, just like we did on sides, you need to conjugate. For surds, we are rationalizing the denominator, but for complex numbers, you conjugate the denominator. Let's say we've got z1, which is equal to 4 minus 2i, and then you have got z2, which is equal to 3i. You want now to find z1 divided by z2. This is the question. How can you work it out? So z1 divided by z2, z1 is 4 minus 2i, and then z2 is 3i. So in a case where the denominator is just 1, like it just has the imaginary part, it doesn't have the real part, just get that same 1 which is in the denominator, multiply on top and down. Just like on sides, we are not changing the sign if it was just alone down. So we're going to multiply 4 times the 3i, that is going to be 12i, and then negative 2i times the 3i, that is going to be negative 6i squared. In the denominator, 3i times the 3i, it is going to be 9i squared. And this gives you, we know I squared is negative 1. Negative 1 times negative 6, that will be positive 6. Then we have got plus 12i. In the denominator, the I squared, that's a negative 1. So we're just going to have negative 1 times 9, which is a negative 9. And so negative 9 into 6, that will be 6 over negative 9. And then 12i over negative 9. We know there's a number that can go into 6 and negative 9, that's a 3. So this will be negative into 6, that will be negative. And then 3 into 6, that will be 2. 3 into 9, that is a 3. This negative into 12 also, that will be negative. 3 into 12, that's a 4. 3 into 9, that's a 3i. So at times they're going to ask you, write the answer in the form a plus bi. So in this case, we've written the answer in the form a plus bi, where we've got a as negative 2 over 3, and then b as negative 4 over 3. So that is how you work it out when the one which is in the denominator doesn't have the real part, just as the imaginary part. Now let's say we've been given a complex number they want us to work out. Let's say z minus, we can say, okay, here z minus 4 plus 2i over 3 minus I is equal to 0. We want to find z. We want to express z in the form a plus bi. What are we going to do? What we are going to do is we are going to get this part, we'll take it the other side of the equation. So this is going to become z is equal to, now this negative, you can see here, this negative belongs to the 4. Therefore, when the It's not the same like this one. If I put like this, then this negative applies to everything. But if there are no brackets, that negative just belongs to the 4. Let me put it in this way. So I'll take it the other side, then the negative becomes positive. So I'm going to have positive 4 plus 2i divided by 3 minus I. So to be able to work it out, we're going to multiply on top by 3 plus I change the sign. In other words, we're multiplying by the conjugate or the denominator. You change the sign of the imaginary part always. So this will give us z being equal to 4 times 3, that's a 12. 4 times I, that is a 4i. 2i times 3, 6i. 2i times I, that will be negative 2. I hope we know why it is negative 2. It's because 2i times I, that will give us 2i squared, and we know I squared is a negative 1. And then in the denominator, when you're multiplying a number by its conjugate, get the first one, square it, plus get the number in front of the second one, that's a 1 squared. If it was a side, we would have used the minus here. So it doesn't matter whether the first one is the one which contains a negative or it's the second one which contains a negative, as long as they are conjugates of each other. So here we've got 12 minus 2 like terms, that will give us a 10. We've got 4i plus 6i, that will give us a 10i. In the denominator we've got 3 squared, which is a 9, plus 1, which is a 10. And 10 into 10, 1. 10 into 10, I. So we have written in the form a plus bi. This is how we work out complex numbers. And this is about complex numbers. The part that is remaining, we call them further complex numbers, so they are not for this time. Okay, let's just do something else. If you are finding the square root of a complex number, let's say you want to find the square root of 2i. We know we can find the square root of 4. What of finding the square root of 4i? How are we able to do it? So when they ask you to find the square root of 2i, whenever they're asking you to evaluate or simplify complex numbers, all they're asking is write it in the form a plus bi. So we're going to say this square root of 2i can turn as a plus bi. Okay, so at this point where we've reached, what are we going to do? Think of removing the square. Now I want someone to help me on this. How can I remove the square? Okay, so I should have said why. How can we remove the square root? We introduce a square both sides. So we're going to square this side. And please, this side, don't square them individually. You don't do that. Okay, so we're just going with a 2i, and that is going to be equal to I plus bi squared. I explained last time, when you've got something in this form, a plus b with a square, get the first one, square it, get the square, multiply by the first one and the second, that will become 2ab, then get the second one, you square it. So I'm going to get the first one, then I'm going to get the 2, I multiply by the a and the b, that's bi. And then I'll get the second one, which is the bi, I also square it. It's going to give us 2i being equal to a squared. Now here, when we square the I, we are going to have, this is the same as b squared, I squared when we expand, when we distribute a square. And I squared is a negative 1. So this is going to be b squared. And b squared is going to be a real number. Why? Because it doesn't have an I. And then we're going to positive 2abi. So we're going to equate the left hand side of the equation with the right hand side. We can see on the left hand side we don't have the real part, meaning the real part is 0. So we're going to say a squared minus b squared is equal to 0. And then we have got a 2 which has got an I. This is going to be equal to 2ab, which also has got an I. Meaning that is equal to AB because the two can simplify. I can make one of them a subject of the formula. Let me make a subject of the formula. That means is going to be equal to 1 over b. I'm going to go in the version where there is a, I'm going to put 1 over b. So that will become 1 over b squared minus b squared being equal to 0. Me over b squared minus b squared being equal to 0. Now when you find the equations such as this, they are going to become a bit tricky. So what I'm going to say is, let x, or just any letter that you want, represent b squared. So this is going to become 1 over x, where there's b squared I put x, minus x is equal to 0. At this point, so I'm going to multiply everything. Okay, yes, Richard?